With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question states, the battery discussed in the previous question is suddenly disconnected. Is a current induced in the other loop? If yes, when does it start and when does it end? Do the loops attract each other or repel? Okay, so this is the sub part of the previous question. So previous question was, two circular loops are placed coaxially but separated by a distance. A battery is suddenly connected to one of the loops, establishing a current in it. Will there be a current induced in the other loop? If yes, when does the current start and when does it end? So it's like we had been given two loops and they were like separated by a distance. Then suddenly a battery was connected to one of the loops. Yes, the current will flow in one of the loops, and because of that current there will be magnetic field. And when this thing is changing, it's not like changing constantly, but for the moment when we connected the battery, suddenly there was magnetic field, and that would induce flux, and flux would induce current. So yes, in this question there will be current induced in the other loop. Now the same battery has been disconnected. Will there be current induced in the other loop? Let's see. So we have two loops. Okay. Number one, we have in the first question, in the previous question, we had connected one loop to the battery. For example, this is our battery. And now in this question, we are disconnecting it. Let's say the circuit is now open and we are disconnecting it. So let's say first the current was in clockwise direction. It's like this. And now that we are disconnecting the battery, there will be no current. But see what happens. When we disconnect the battery, first there was first when it was connected, there was current, right? And there was magnetic field. Let's say in this direction. Right? Initially when this was connected. When suddenly we disconnected, the current will decrease. That decreases the magnetic field, right? And there is some change. Change can be anything. It can be like increasing or it can be decreasing. Right now this thing is decreasing, and when this thing is decreasing, change is there, so current will be induced in the other loop, but only for a second. Say like when we disconnected, current like suddenly stops, but that doesn't mean the magnetic field will suddenly stop at that moment only, like at the moment we turn this off. But it's like it would be there for a second, it would start decreasing, and then it would vanish. So we can say for a moment, like for a second, there will be induced current in this, and for that second we have to apply Lenz's law, which states that the direction of the induced current would be such that it opposes the change that is causing it. What is causing the change in this loop? That is decreasing magnetic field. So the direction of the induced current is such that it increases the decreasing magnetic field, right? It has to increase the decreasing magnetic field. And how will it do that? If initially the current was in the clockwise direction, this will also be in the clockwise direction. And we know when two currents are in the same direction, they attract each other, right? So clockwise will attract clockwise. So these loops will attract each other, and they both will be either in anti-clockwise or clockwise direction. So that gives us the answer. Is a current induced in the other loop? Yes. If yes, when does it start? It starts like as the magnetic field starts changing, but it stops when the current is zero in the other loop. Do the loops attract each other? They attract each other because the currents are same. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.